Today we're going to begin Unit 8, Probability. Now, probability is actually kind of fun, and it's not even that difficult. We're going to talk about the fundamental counting principle and probability. So let's look at some stuff. A class is choosing a president, vice president, and a treasurer. Find the total number of outcomes given the following. Well, and as I make this larger, let's take a look at this. You can represent this a couple of different ways for the total number of outcomes. You can make a tree. You see, okay, if Linda's president, she could have Jim, Bob, or John as a vice president. And if she has Jim as a vice president, she could have Jessica and Amanda as a treasurer. So if you do a tree and you count all those things, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible outcomes. Okay? A tree is a legitimate way to do it, but a tree takes up a lot of space. So when you start getting into maybe 3 and 4 people running for president and then 5 students running for vice president, you don't have enough paper or table space. So now what we're going to do is we're going to notice, I'm going to point something out to you. 2 people running for president, 3 people running for vice president, and 2 people running for treasurer, right? Let's see what happens when I draw parentheses around this. 2 for president times 3 for VP times 2 for treasurer equals 12 total outcomes, possible outcomes. And that's what we have in our tree. We have 10 possible outcomes. You've got Maria, Jim, Jessica, Maria, Jim, Amanda. There are 2 right there. And we can even pick things out. Let's just say I'm gonna include a new one. How many have Amanda as treasurer? Well, let's look at the diagram. Amanda as treasurer, 1, 2, 3, 4, 5, 6. 6 have Amanda as treasurer. That was so easy. Alrighty. Now, I'm going to move my notes a little bit because these are some packed pages. Let's see if I can undo that because I just made a big mess. All right. Oops. Trying to move this up, and I don't think I can. All right. I'm going to clear my page. I'm going to move things and clear my page. Sorry, guys. We just really packed everything in here. And I want to make sure it's as clear as possible. So, clean up my mess. All right, and then I'm going to actually put this back up here. 2 times 3 times 2 equals 12, so you can see that. All right, now let's look at another one. There are 3 sandwiches, 1 drink, and 3 desserts available at this restaurant. You're choosing a sandwich, drink, and dessert, so how many lunch specials are possible? You multiply everything. 3 times 1 times 3 equals 9 lunch specials. You simply multiply all the options. All right, let's look at B. When ordering the kids' lunch at Burger Universe, the customer must choose a size. I'm going to get a different color. Got to choose a size, type of bun, side order, and type of fruit drink. I underlined them so I could keep track of how many things I have. So now we're going to use the chart. How many sizes are there? 2. How many types of bun? 2. How many side orders? 3. And how many fruit drinks? 4. So how many kids' lunches are possible? 2 times 2 times 3 times 4. 4, 12, 48. 48 possible combinations. Fundamental counting principles, pretty easy. All right, now we're going to talk about probability. Now, probability is what you want, I'm getting them all set, over the total possibles. What you want to choose out of how many possibilities there are. So what I want you to do when you're writing out probabilities is to write the total. So how many marbles are in there? The total. There are 10 total marbles, so that's the total number of possibilities. We want a white marble. We count them. There are 2 white marbles. So there's a 2 out of 10 probability. Keep it in a fraction. That reduces to 1 out of 5. All right, you try. With the same color, you try it, and then come back to the notes. All right, I've got a bag with 6 marbles. I'm going to start my fraction. 6. What's the probability that the marble is gray? I have 1, 2. I have 2 gray marbles. So I have a 1 out of 3 chance of picking a gray marble. Now, I know you're thinking, but I'm only picking 1. But there are 2 in there. So 2 of the 6 marbles are available. And let's think about it this way. I'm going to pause for just a second. Okay. Let's do another one. I have 10 students. And 6 wear blue. What's the probability that I close my eyes and pick a student who's wearing blue? Well, 10 total students. I want somebody wearing blue, which is 6. That becomes 3 out of 5. It's really not difficult, which is nice. Nice, you deserve something good. Now we're going to talk, so you got probability equals what you want out of the total. The fundamental counting principle, all the possible outcomes, we multiply them all up. Now here, outcomes and events, you are going to have a chart and you are going to choose how many times the event will happen. The event is the thing you're doing, whether it's rolling a die, flipping a coin, spinning a spinner, picking students. That is an event. Now, a coin is tossed 3 times and an outcome is used by a string of letters. HTT meaning head on the first, tails and tails. There are 8 outcomes. How do we know there are 8 outcomes? There are 2 outcomes the first time you flip a coin. There are 2 outcomes the second time you flip a coin. There are 2 outcomes the third time you flip a coin. 8 possible outcomes, 8 possible combinations. So let's look at this. I'm going to look at this chart. First, we want to find a head on the last toss. So you go through and you see, okay, they have a head on the last toss. I'm looking for an H. Doesn't say only one. It just says head on the last toss. So read the event carefully. There are 3 out of 8 events. I can't reduce it. Now I'm going to do alternating heads and tails. Either one can come first. Well, HTT doesn't alternate, but HTH does. That doesn't. Oh, this does. And we only have 2 that alternate. So we have a 2 out of 8 probability, which reduces to 1 over 4. The last one we want is exactly 1 tail. So look at all these possible outcomes. You're looking for 1 tail. Well, this one has 1 and 2 heads. This one has 1 and 2 heads because the outcome didn't say where, it just said 1 tail. And this one has 1 and 2 heads. So this outcome is 3/8. All right, let's go to the last page. Probabilities with 2 die, which should be actually 2 dice. I will make sure you have a physical copy of this table. You may use this physical copy of the table on your test and on your homework and on your quizzes. I don't expect you to write it, so I will give you a paper copy. Now, what this chart says is roll the first die, roll the second die. So when I roll the first die and I get a 1, I roll it the second one, I get a 1, I add them together. All right, so this chart is the sum. Now remember, a regular 6-sided die has only 6 sides, so you can only go from 1 to 6. So the lowest number you're going to get if you roll twice or roll 2. Roll 1 die twice or roll 2 dice once. The lowest number you can get is 2. The highest number you can get is 12. Oh, first of all, how many possible outcomes are there? Well, let's do some really simple math. It goes 6 across and 6 down. What is 6 times 6? 36 total outcomes. 36. Now this is fancy writing. PA is the mathematical way of saying what is the probability that event A happens. Event A is the sum is greater than 7. What is the probability that when I roll 2 dice, the sum will be greater than 7? Well, we still want to do want over total. So my total is going to be 36. It's total possible outcomes, but I want a sum greater than 7. I didn't say equal to 7. I said greater than 7. Let's get highlighters. So I'm looking for, 8, 9. That's all. I'm highlighting all those that are greater than 7. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 outcomes where the total is greater than 7. I want you to reduce that. You need to be able to find common factors, and 3 is a common factor. 5/12. And yes, I will take off points if you don't reduce. It is a mathematical requirement. So now, let's look at event B. The sum is not divisible by 4. Well, I still have 36 possible outcomes, but I want the sum is not divisible by 4. Okay, so what are numbers that are divisible by 4? 4, 8, and 12. Divisible. Too many L's. Divisible by 4. Let me see if I can get rid of that little L. There we go. So now, whoops, I'm going to highlight what numbers are not divisible by 4. Well, I'm going to just put X's through them. 1, 2, that is 3, 4, 5. 8 is 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. And let's double check. If 4, 8, and 12 are divisible by 4, I have to make sure I did not highlight 4, 8, and 12 in red. I did not. 1, 2, 3, 4, 5, 6, 7, 8, 9. I did not highlight. I have 9 unhighlighted. Good, I did it right. 27 are not divisible by 4. Reduce this, the common factor is 9, 3 over 4. There's a 3 over 4 probability that I will roll 2 dice and get a sum that is not divisible by 9. The tables are good. You are simply looking and counting, but you have to understand what the words are telling you. You have to understand what the event means. Now we're going to stop. I want you to try, mark up this thing. Again, I will make sure you have a paper copy in class. Mark it up, and then come back and see if your answers match mine. All right. We still have 36 total outcomes. That doesn't change. So something over 36. I want the sum is less than 6. Less than 6. Not less than or equal to, but less than 6. Okay. That's 2, 3, 4, and 5. That's it. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 out of 36, which gives me 5 out of 18. There's a 5 out of 18 probability that if I roll 2 dice, I will get a sum that is less than 6. Okay, let's do another one. Event B, the sum is divisible by 3. Well, we know there are 36 possibilities. Let's write down numbers that are divisible by 3. 3, 6, 9, and 12. Divisible by 3. Let's go back to the chart, and we're going to put marks. We're going to highlight all the numbers that are not divisible by 3. You want to do something that's actually easier? I'm going to highlight the numbers that are divisible by 3 because then it's a lot easier for me. Why? Because I'm all about doing it the easy way if I can. 3 is divisible by 3. 6 is divisible by 3. 9 is divisible by 3, and 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I found that 12 are out of 36. That means that 24 are not. I like doing things the easy way if I can. All right, so now that we know that we have 12 that are divisible by 3 and 24 that are not, we put in what is divisible by 3. And we found that the probability of rolling 2 dice and getting a sum divisible by 3 is 12 out of 36, which goes to 1 out of 3. And just for grins and giggles, the probability of not rolling a sum divisible by 3 is 24 out of 36, or 2 over 3. All right, that sums up Unit 8.